Number 5, they give us a straight line graph, and just like some of the problems before, we've been asked to find the volume of this solid when you rotate around the x-axis, which we've done before in a couple of the problems. So you might be thinking, oh, this is really easy. But they don't give you a slope of the line or an equation for the line or anything like that. But it does, you do notice it's a perfect triangle. So what they're trying to scream out to you when you see this problem is that it becomes a cone. And we do know the equation for a cone, which is v equals 1 over 3 pi r squared h. And they even tell you this by giving you the length and the width and height of this triangle in h and r. So they're trying to say radius and height. So the easiest solution would be like, oh, if I'm looking for the volume of this, it's clearly just going to be v equals 1 over 3 pi big R squared times h. And you go, oh, there's my answer. I personally think that's not the intent of this question. What if you get a question like this from your interviewer, they don't want you to just spit out the volume of a cone, which you do need to be able to do, but I think this is more about actually being able to derive the common equations for certain shapes we have. So if you got asked a question like this, the second method that I would do is treat it just like any other problem. And you have to define your differential just like we've done before. And you know v equals, oh, that's wrong. Delete that. V equals the triple integral of rho d theta dz. And you can pull out the 2 pi. We've done it longhand before, but this d theta is always just going to become 2 pi, so you can just multiply that in. And you get left with the double integral of rho dz. And now you have to talk about your limits of integration, which we're going to do real quick. On the z-axis, which I flip this graph around, so it's easier for us to have a line and some limits that we can work with. Your z-axis is going to become, it was your x-axis. So if we do 0 all the way to z to h, there's one limit. And then for our rho, which is our y, having lots of interruptions here, is going to go from 0 to the slope of this line, right? So we have to create that little slope right there. So if we had a line like this, you then have to use another one of your skills, and you go y equals m plus, y equals mx plus b. And you have to be able to build this formula. Here you get, in this situation, y becomes rho equals slope, which is just going to be rise over run here, radius over height, times your x, which is z, plus 0 y-intercept. So this right here is our equation, and this is going to be our top limit for rho. Gives r, h, z. All right, and then you plug it in, and I'll be back when we solve this integral. All right, and just as you expected, we get an answer that gives us the volume equation for a cone. And again, I just want to reiterate that this question seems strange, like, oh, I know the volume formula, I can just plug it in, and you can do that, but your interviewer is going to be asking you these questions to test if you see if you know a certain piece of knowledge that he wants. He doesn't really care that you can verbatim memorize a few formulas. He or she is interested in knowing if you can think and solve a problem that he's presenting to you in a different way. So be able to derive common formulas like this is more important than just knowing them. Problem 6 gives us a bit of a real-world style problem, but at the root of it, you're just going to identify that it's a polynomial equation, and you're being asked to graph it again. So we're going to do some derivatives and second derivatives and find some key points, some critical points, and some points of inflection, and then put together a graph, just like we did before. So first, if you take your equation, 10 plus 6t plus 2t squared, it's going to be an easy derivative of 6 plus 4t, and then an easy second derivative of 4. So a few things you can learn right off the bat, as you know it's concave up. Next step is to set your first derivative to 0 to find your critical points. So you're going to get an easy t equals negative 3 over 2. If you plug this back into the original equation, You're going to get 10 plus 6 times negative 3 over 2 plus 2 times negative 3 over 2 squared. You get 10 minus 9 plus 9 over 2. If you square that, you're going to get 9 over 4, and then the 2's cancel, you get 9 over 2. And this equals 11 over 2. So we have a critical point at negative 3 over 2, 11 over 2, and our graph's going to be concave up. I drew that in for you already. This is what it's going to look like. That's all you have to do. Part B is asking us to find the neutron increase between t equals 10 and t equals 11. You do simply just plug in 10 and 11 into the original equation, and you subtract the 2, and that gives you a net n. For part C, you're being asked to find the rate, which is the first derivative, right? A rate is equivalent to the slope of the original equation in this real life example at 10.5. And again, this is going to be really simple. You're just going to plug in t, 4t plus 6. You do n prime at 10.5. And that's going to equal 4 times 10.5 plus 6, and that equals 42 plus 6, which is 48, and that's your rate. And again, this problem isn't trying to trick you and saying, hey, can you plug in a number into an equation? But the point of the question is, do you understand what a rate is in relationship to this initial equation? And yes, I know that a rate is the first derivative of a polynomial expression, and that can work from there. And then just the same way, if I wanted to find the acceleration, it would be the next step beyond that, taking the second derivative, and that's the change of rate for that problem. Part D is asking you to relate C and B. I think it's a very mundane question. Essentially, the idea is that a change over a time interval is approximate to the rate. And this isn't absolute or exact because the rate of change at 10.6 is slightly different than the rate of change at 10.4, but you're estimating that if the rate is constant for one time interval and we're breaking things up, our intervals into seconds, then the difference in neutrons at t equals 11 and t equals 10 is your rate of change at 10.5 right in the middle of that time interval.